This is a second part of TreeSet under collection framework. Here we will discuss about using comparable and comparator in case of the java.util.TreeSet class. I have already added the link of its part 1 in description, or you may use the I button to go to the first part of the TreeSet video. You know already that all the tree based collection uses a sorting mechanism to add or search elements. So for this purpose, we need to know about using comparable and comparator. So for this purpose, I am going to create 3 classes: student, employee, and test. So let me start with the class student, and here I will use tools field as role and name. Let me create setter and getter. So this is nothing but just a Pujo class with get role, set role, get name, and set name. So it's simple. And one more thing I want to add, that is a constructor for it, with the role and name as a parameters. And one more thing I want to add to a string, so that when we print the string object, we can see a fruitful information instead of the hash code. Let me do that. So there is a student class with the 2 field, role and name, 2 string method to display role and name, get role, set role, get name, set name are the setter and getters. And let me add one more class as employee. I will also use 2 field as int and id and name, and having the same set of things like the setter getter, one parameterized constructor, and overriding just a 2 string method to get a fruitful information. Here we will return imp id and name. Let me create a test class with a public static void main, so that we can test our example. Now I'm going to create a TreeSet object. For this, we need to import java.util.TreeSet. So let me create TreeSet of student set ss is equal to new TreeSet. Now I need to import, so just control space, and you will have the importer statement. Now we can add some student object in this set. Roll number and some name. Now let me execute this program and see, is there any error? Because we are using TreeSet, we have some dependency to use this class, because tree always adds some element. Tree always adds any element after comparison. Okay? Why? Because we know that tree based collection uses a sorting mechanism to add or search element, but we haven't given anything like sorting mechanism into the student class. Let me show you the error. So run file, and you will see that there is a error of comparable class cast exception for comparable. So this is what this says, that we should implement the student class with comparable. So let me implement the student class comparable. So if we are using comparable, then we should have a method implemented in this class, otherwise the student class becomes an abstract class. So let me override that method. And there is only one method need to be override, and that is compare to. And from this method we will write code about how we will compare two different objects of the student class. Here I guess that two students must have unique roll number, so we can compare with the help of roll number that this student is unique. So just typecast the object O to some student object, and then return as dot get roll. Or since we are in the same class, we can also use roll minus the current object's roll. So in this way we are returning the comparison. Either it will return positive or negative or zero number. If both have the same roll number, then it will return 0. If greater, it will return positive number, and if smaller, it will return negative number. Let me show you now what the test.java program says after execution. So there is successful execution. Now let me add one more object of student here with some different roll number, name as B Baja. So let me show you the execution. It is successful, and let me display the object. You can see the roll number 14, the roll number 12. If you want to change the order, just go to the student.java and change this to this one. Now it will compare in reverse order. So let me execute and show you the output. You can see now 12 is the first element and roll number 14 is at the second element. No matter that what is the sequence of object added to the set, the order will be decided by the sequence of the roll number. This compare to method will decide how the object will be added, in what sequence the object will be added. So anytime you can change the sequence, just ascending or descending order, by just changing these two things, current object dot roll minus passing object dot roll, or passing object dot roll minus current object dot roll. We can add as many objects as we want. So let me add some more object here with different sequence and with different name. But here name is doing nothing. Here is the most important thing is comparable part. That is the compare to method, which is using the roll number to compare between two different objects. So whatever the sequence of name is, it doesn't matter because we are comparing on the value of roll number. So it will always add the objects according to the roll number, 12, 13, 14, 16 and 18. Okay, and now if we will change this comparison by passing object minus current object's roll, then we can see the result in the reverse order. This time 12, 13, 14 is coming, and after execution we will see the reverse order 18, 16, 14, 13 and 12, that all numbers are. Okay. If you want to compare, if you want to add object according to the name, then just go to the compare to method and change as dot name dot compare to passing object. Now everything will be sorted according to the name. L, K, D, B, A. So in this time we are having the names in sorted order. Okay, and we can change the order in reverse by just current object compared to passing object's name. And you can see A, B, D, K and Mr. L. So in this way we can add. Now one more thing is that if we will add one duplicate object, that means we are going to add an object having same data as earlier, then it will never add it, because the compare to method will not allow this duplicate object to be added to the set, tree set. So you can see Mr. L is only once added into the set. Now, but this is having a problem that we can either use roll number or name to sort. If you want to sort on different columns, then comparable is helpless, because it can either use name or roll or any one field to compare. But if you want to do something else, like when you have already your Pojo and you want to sort on different columns, then comparable is helpless. So in this case we need something else like comparator. Okay, so let me show you how we can use the comparator. For comparator I have made employee.java having no comparable interface implemented, a plain Pojo with setter, getter and a toString overridden. So how can we use? For this we can create our own comparator. Like if you want to compare on ID, then we can create a comparator, separate comparator for it by comparator. So here we will create our own comparator. If you want to sort on name, we can create a name comparator, which is outside the Pojo, which is outside the employee.java class. We have to implement one method here so that we can compare. And in this, from this compare method, we can compare between two different objects, one O1 and O2, which is of student type. If we are using the student object to be added. If we are using employee type, then we have to think about it. At which type of class we need to add it. So since we are using ID and name, which is the field of employee, so I will use employee object to be compared. So we will create typecast and then since it is ID based comparator, So I will use e1 dot id, e2 dot id, and similarly we will make the comparator for name also. Just I am copying the above code to avoid typing mistake, and here we will use the name comparator. So in this way we have created a name comparator and ID comparator which is outside the employee.java file, outside the employee class, the place where we want to add the employee object into the set. So what to do is we have one more constructor to create object of TreeSet. Let me change the variable to ES and convert this normal TreeSet to be comparable with the help of comparator. So just pass the comparator object. Okay, so now we have ES TreeSet object with the ID comparator as a parameter. So now we can add employee object with some employee ID. Let me execute this program and see what will happen. Now you can see, since we are using ID comparator, now you can one more thing you can think about it, that the student class implements comparable but employee class doesn't. Even then we can use the object of employee class in TreeSet because of this comparator. Okay, so we can see here, since we are using ID comparator, you can see that we have items elements sorted on ID. And now just change the comparator to name, and you can see that now sorted at the name ABK. So in this way we can use comparator, and anytime we can change the column to sort the items according to the comparator. Now here also you can see that if we will add an object with same content with different ID, no matter what ID is, because we are using name comparator, whatever the ID is, no matter, since the name is same, it will not going to add into the set. You can see A Raja, B Raja, K Raja. Okay, no duplicate value with 17 B Raja because the comparator is name. Okay, now if I will do one thing, 15 with some different name, now it will be added because we are using name comparator, and it will be added, no problem. Even when the roll number is same, no problem, because the comparator is name. So all the 4 items are added with the sorting order of name. But when we will go to change the comparator with the ID comparator, now this object will be not added into the set because the same roll number is, the same ID is with added earlier. Let me check. You can see A Aja, K Aja and B Aja. This object is not added. Employee ID 15 is already added in the set. So in this way you can see that no duplicate object is possible, since we are using only employee ID or only name as comparison. So no duplicate value is added because it is a set. And how we can use comparable for single sorting and comparator for multiple column sorting order. In comparator, since we can avoid the typecast of employee here by just providing the type of the object we are going to handle. So now the object becomes employee and there is no need of typecast. Just go and use O1, O2 and use. We are already using ID comparator. Just let me check. Let me show you the result. There is no problem. So if you are passing the type of object here, then there is no need of typecasting that we are using here. We need to typecast here because we are not explicitly giving the class type whose object will be compared. But in case of ID comparator, we have added this type, so we don't need to explicitly typecast. So I guess you have more clear view about comparable and comparator while using TreeSet. And if you want to iterate, I have one thing for you. If you want to iterate, then you can say es dot descending iterator to iterate the things in descending order. I guess you all of you have used Iterator, but just to explore how we can use Iterator, I am just giving you an example. Import statement is added to use Iterator, and then just a small while loop with itr dot has next, and just pass the type of object and then get each object. And since I have already overridden the twisting method, I can just print. No need to call the twisting method, but these 3 lines will help you to iterate and see all the objects one by one. In this way, I have all the 3 objects that is going, and that is printed with the help of this statement. So you can fetch all the elements from the set with the help of iterator. And you can see, since we are using descending iterator, so items are added in 12, 13, 15 in this order, but items are in your hand in reverse order because we are using descending iterator method. So that's all for today. I guess you have understand the comparable and comparator in case of using TreeSet. So thank you very much.